Okay, today's lab is Introduction to Motion. The whole purpose of today's lab is for you to get the feel of how your motion translates into motion graphed on a position versus time and a speed or velocity versus time graph. Now, in terms of theory, all of our theory can be summed up in this one equation, that the average velocity is equal to the change in displacement divided by the change in time. Now, we're going to have our motion sensors that are going to be taking data at, depending on which part of the experiment you're in, either 20 times per second or 5 times per second. And so that delta t is a small amount, and we'll be measuring the position at each one of those times. And if we know the position and we know the time difference, well, we can calculate the position change, the time difference, and thus we can calculate the average velocity in each one of those intervals. And even at 1/5 of a second for the time interval, I think we'd be fairly comfortable in saying that's pretty much an instantaneous speed. Although I have to warn you that in the time of 1/5 of a second, you move, and if your motion is just a little bit bigger than the last 1/5 of a second, it'll look like a much bigger velocity. So the velocity graphs will have what looks like a bunch of noise to them. And what we care about in this graph, or in this lab, is just the qualitative behavior. So really what I care about is the general motion here. I don't care to see all of those jags. When you're drawing graphs, it says make them qualitative. You don't need to have the numbers there. You just need to have the general trends. Now, something about the graphs. Make sure that your graphs have a meaningful title. Right? Position versus time is not a meaningful title. You can just look at the axes and see the axes need to have the labels. So the horizontal axis should have the label time. It should have the units, parentheses, seconds. The vertical axis should have the label. So for instance, position, parentheses, meters. So position versus time is known. Your meaningful title should say what you're looking for. So you're going to be doing something like, graph showing motion while walking. That's meaningful. It's telling you what the graph is doing. So you need to have a meaningful title. You need to have each axis clearly labeled with the units. Even though we're not putting numbers to it, we should still have units there. And finally, make the graphs large enough so at least 2 to 3 inches tall and 4 to 6 inches wide, right? We want these graphs to be big enough that we can actually see trends and whatnot, not just like, well, it's a little thing and there's a line on there. Another thing, when you're using graphs with the Pasco system, make sure that you rescale the graph so your data is completely filling the graph, not just a little part of it. Okay, moving on. I'm not going to go through the theory. We've talked about this in class. What we're going to do is we're going to experience the process. So we're going to be using these Pasco. Pasco is the name of a company. That's Paul A. Stockstead Company. He is the Seventh-day Adventist, and he gives us very good discounts on the equipment. So I just want to make sure we get his name out there. We're going to be using just 2 things. You will be using the Pasco Scientific Workshop 850 Universal Interface and the Pasco Motion Sensor 2. So those are the only 2 pieces of equipment you're going to be using. And that motion sensor 2 sends out a 50,000 hertz, 50 kilohertz chirp. Now, you can't hear 50,000 hertz. You'll hear a click, but that click is just it turning on and off. It's not the actual chirp that's sending out. That sound wave then goes outward. It hits an obstruction. So here's your body. And then the sound wave reflects off your body and comes back. And the little sensor is going to measure the time between when the sound was emitted and when the sound returned. And based on the speed of sound, which at room temperature in theory is 343 meters per second. If your room temperature is warmer than 20 degrees Celsius, well, it's going to be faster. If your room temperature is colder than 20 degrees Celsius, it'll be slower than that. In this lab, we only care about qualitative numbers, so we're not going to worry about calibrating for what the exact speed of sound is. We'll just go with that's an approximate number, and it'll give us approximate distances. So it's going to measure the distance you are away by how long it takes for that sound to go out and back. These sensors have on the top of them a little switch, and above the switch you have a picture of a cart and a picture of a person. It should work better if you put the switch over here for the person. The difference is the width of the beam. If you find that it's not working very well, try switching it to the other position. Okay, so what are we doing in the lab? Well, first, we're going to have the scientific method for almost every experiment we do. And this one here, our scientific method needs to be something that can be tested by the procedures below. Now, you have to start with an observation. And the observation is going to have to be on some actual motion you've seen. I was looking at some students' proposed observations. Their observations was, I noticed that I can move faster and slower. They didn't have a specific case. I want to see a specific case, something like, when I leave a stop sign in my car, this happens. Something that talks about the motion that relates position, velocity, and time. Your hypothesis has to use the equation delta V, not delta V, excuse my delta, should have been V average, is equal to delta X over delta T as its reason. That really needs to be the reason for the hypothesis. So the hypothesis says this was observed because of this, and go from there. And then, of course, your test should be from something in the procedure. Now, you need to be clear about that. Something in procedure. What are you going to do that is going to test your hypothesis, and what result will be consistent with it? Okay, now for the rest of this, I'm going to go through just a little bit of the experiment stuff. For the most part, just read through it and follow the instructions. And then I'm going to go to the software we're using to explain how to use that. So you're going to open the Intro to Motion Capstone module, go to tab 1, which is part 1, distance versus time graphs. And the first thing you're going to do is you're going to have, between you and your partner, make these 4 lines. Now, in your lab book, you'll just make one graph. So this is going to be, graphing, whatever. And you'll have position. Didn't need to do that. There's got to be a way to make that go away. There we go. So we're going to have position in units of meters, time in units of seconds. And you are then going to put 4 different lines in here. Now I'm going to make 4 little lines that have nothing to do with reality. I made those 4 lines have nothing to do with reality just so you won't say, oh, I'm going to put like this. Remember, you want your graphs to be much larger than that. You need to make sure you label them. So have something, that says this one here is, whatever the description is. And each one you should have some kind of description so it's clear what each one of those lines are on the graph. For doing this, notice there are 2 lines here that say slowly. And there are likewise 2 lines that say away. So one partner should do slowly away and quickly or moderately fast toward. And the other partner should do the remaining ones. The idea here is that each partner does a moderately fast, each one does a slow, and each one does a going away, and each one does a going toward the sensor. Then you have your questions to answer here. I tried to put in bold anything that you're going to sketch or print. So notice, using a dashed line for your predictions, sketch a new qualitative graph of what you think will be produced when a person starts 1 meter from the detector, walks slowly away for 3 seconds, stops for 3 seconds, and then approaches the detector for 3 seconds. So you're going to draw a graph of what you think the position versus time is going to look like. After you've drawn that, then you're going to do the motion and sketch on the same set of axes what it actually was with the solid line. You're also going to print your best effort, not your partner's, but yours, so that you have that. Now, I'll talk about the printing in just a few moments. Then you have your questions. You go on. There is a prescribed data set. I'll show you how to bring it up. You're going to put that prescribed data on the screen, and then you're going to walk to try to match that. So first you're going to have to describe how you're going to walk to do it, and then try to do it. And again, print your best effort and answer questions. This is a new section between QC5. They're the sketch your own. So this one you're making up your own position versus time graph. You need to use straight lines, no curves, and at least 3 different speeds. Describe the motion that you'd have to do it, try to match it, and print your best effort. Part 7, don't try to replicate these, just describe what you'd have to do to make those happen. Roman numeral 2, we'll go to the second tab, and now you are simply going to do the same things you did before, but you're going to be looking at velocity versus time graphs instead of position versus time graphs. So follow through the instructions here, but it's basically the same as what you did before. Roman numeral 3, part 3, relating position and velocity graphs. Now we're going to switch to tab 3, and we'll see position graph on top, velocity graph on bottom, and you'll have a predicted line on there, and you're going to try to replicate it. So just follow through. It's pretty clear. Let's, obviously I can't ask if there's any questions, so let's just go now to what the program looks like, the Capstone Program. So here's the Capstone Program. Things to notice, over here on the left, we have things to do with our data. So the top one, hardware setup. Click on hardware setup, and that is supposed to open. Let's say my computer is going slow right now or something. It's totally not opening. Well, let's try data summary. It's not even recognizing my finger touch. Okay, there's the data summary. Right now it's showing little exclamation marks in triangles. That means that my hardware is not currently being detected, which to me is somewhat troubling. It was being detected when I started this presentation. I'm going to unplug the sensor and plug it back in and hope for the best here. Well, that's not the best. It malfunctioned, it says. Well, let's try plan B. Plan C is that we don't actually get this to work. I saw while I was doing this that the interface did something funny, and apparently, well, now it's working. Okay, so now the data doesn't have those triangles. It's working. Go to the hardware setup now. Now it works. Here we can see what looks like, what your interface looks like. The motion sensor there. I have it plugged into position 1. It should work just fine in any position. Let's see. Unplug it from there. Oh, big problems. Plug it into position 2. It just moved it over. So you don't have to really worry about it as long as you have the motion sensor plugged in. So let me go ahead and close that. The calibration we'll be worried about for other things later on. I've got the 3 tabs up here, tab 1, tab 2, tab 3, for as we go through the experiment. So let's say we're doing the first one. Now I'm just going to use my hand for my position. I'm just going to randomly move it around. Down here at the bottom, notice here's the frequency, 20 hertz. We're doing 20 measurements per second. If I hit record, it'll start taking data. Move my hand, it's recording the position of my hand. Those little hiccups are because apparently my computer, in this case the Surface Pro, isn't fast enough. Okay, so there we have some data. Now, if I did this for a real experiment, I wouldn't use it. This data that's down here all at zeros, that was a hardware failure. That wasn't my fault, but there's definitely not good data. So notice right here, I have delete all runs, delete run 1, or delete last run. So in this case, all those would be the same. Delete it, and let's try it again. Okay, there were still 2 hardware failures there, but I'm going to stay with that. Now, if I were to print this, this would not be good. This would be lost points because my data is only in a small section of this big graph. There are two ways to rescale the data. One is to put my cursor here on the side so I have the up and down arrows. Oh, you see the software or the hardware is just not recognized again. And I can scale it like that. Likewise for the horizontal. Now, see that hand? If I have the hand, it will actually move the data. The second way is this button up here in the top left corner. If I click that button, it should, all things being well, rescale the data so it fills the entire screen. So that's the best way to do it. I did that, it rescaled, it fills the entire screen. I'm good with this, I can print it. So make sure you pay attention and rescale the data as appropriate. Now I can take another, well, I can't take another data because, of course, I had a failure once again. I power cycle, we'll see if that turns it back on again. It did. So let's try taking a second set of data. Okay, that didn't have, well, it had hardware failure right at the beginning, but otherwise it worked right. So there I have two lines on there. What if I only want to look at one? I don't want to delete them both, but I want to only look at one. Well, that comes to this third item up in the top right. The thing that has the triangle with the rainbow colors kind of looks like a Google Drive symbol to me. It stands for data with Pasco. So I'm going to click on the arrow next to that, maybe, and it brings up and allows me to choose whatever has a check mark it will show. So there's just run one, or just run one. Now I have both run 1 and 2. There's just run 2. So you can choose what's displayed. Turn them all on. Come here. Let's say that I just want to delete run 1, but not run 2. There, I deleted it. Now it's gone. Bye-bye. I'm actually going to delete all the data. We have a prescribed data, something that you're going to have to try to match. So there I turned it on. Don't want this blocking it, so I need to, okay, this is there. Move that out of the way just by dragging it. Now I'm going to need to try to walk to match this. So you're going to need to describe how you're going to walk to match that and then actually do it. Now, you are asked at multiple times to print things, like your first 4 graphs, do them all at once and print them. I showed you how you can select, so you could have done 7 of them and said, well, these are the correct ones. To print it is kind of tricky. Up here at the top, this is supposed to look like a camera. I'm going to click on the down arrow beside it, and we have 3 options. Don't choose the top one. I'll show you what the top one does. So here I'm on the top one. I click in the middle of the camera, and it takes a picture. There it popped up. Now it's gone. Man, what if I wanted to see that if I wasn't sure what I had? Click the icon right next to it, and over here on the right side, continuously growing, that's scaring me, is the journal that shows the pictures I took. Now notice with that top setting, which was showing the snapshot of the entire workbook page, it has all of the menu stuff. Well, I don't care about the menu stuff, so I never use that one. The second one is snapshot of the workbook page content. Now I'm going to add something to the page so we can see it. So position, yeah, that was a poor choice. Okay, who cares what I put on there? I have 2 displays on there. Let's say that I do the second option there. The second option being for pictures, snapshot, the workbook page content. That's going to show all of the content. So let's just take a picture and see what it looks like. Take a picture, Sesame. So there we have it, and you see it's just, it doesn't show all of the extra stuff around it, but it shows both of the things on the page. But what if I wanted to see the graph? Okay, so now I have the graph selected. Notice part of the graph is under the table, but the graph is the only thing selected. If I go to the bottom one, snapshot workbook page display, then only the one that's selected is it going to take a picture of. So this third one, that's not right. There, apparently I took that one before because you notice that it wasn't right. I'm going to select the other one just so you can see. There it took just the one I had selected. Now I have the other one I believe selected. Wow, it shouldn't have shown the one in front if I understood it to be correct. Okay, but you can see the difference. So for taking your pictures, and you know what? I don't know how to delete that from this interface. That's a bad thing. Well, it doesn't really matter because it's only instructional. So when you're taking your pictures, this is how you take them. Now over here, I might have said, okay, I didn't want that one, so let's delete that picture. I definitely didn't want that one. Didn't want that one. I'm deleting a bunch of pictures because these pictures are not pictures I wanted. Okay, I got rid of all of them. So let's, well, I don't know how to get rid of it. I know how to make it tiny so it doesn't matter. So there I have the picture I want. Now, I'm working with a partner, and if this is just my data, I'm going to put here something to say it's my data. So that should say Richard's data or some facsimile thereof. Didn't need that return now, did I? Okay, so there I have it named. That way, when it prints, it'll show that name. I'll have it with it. Now, when you turn your lab, you're turning in a PDF file, right? So when you go to print this, it's best if you print to a PDF. Print to a PDF you'll have as a file. You can just email that file to yourself. Use the PDFill tool to split it up, rotate, whatever you need. And so I recommend just printing as a PDF. I'm not even going to waste my time doing it. So that's how you are going to take pictures and, well, make graphs and print them. You have later on some other things we're going to have to do. One of them is we're going to find the slope. So to find the slope, notice I selected data. I had to do that for this little pencil with the dots above it. That gives me my data select tool. And now any data that's in this box is my selected data. I can change the size of the box to change the data I'm selecting. Now I want to find a graph. So this here is my graph tool. These are all the different kinds of graphs I could choose. So let's say I wanted to fit this to a cubic equation. There, I chose cubic. Here is my cubic fit. And you know, you can see the slope. A is the constant, that's the y-intercept. B is the slope of what we consider for linear. And then the next two, the x squared and the x cubed, those are very, very small numbers because this is essentially a straight line equation. Well, what if I'm smart and I say, wait, let's just do a linear equation. So I'm going to choose a linear equation, turn off the cubic, and there's my linear equation. So there's the fit to the data. So you have the slope m, the y-intercept b. R is a number that tells you about the goodness of the fit. If r is equal to 1, it's a perfect fit, which this should be because this is made up data. That's a perfectly straight line. So that's how you can find the slope. Now you also are going to be asked to find the average. This capital Greek sigma is our tool that gives us statistics. And I'll turn all of these on just so you can see them. If you click the sigma button, it turns on and off the statistics. And so you can see here the maximum, the minimum, the mean, and the standard deviation. And now I'll go ahead and turn off everything but the mean because that's what you're going to be looking for when you use it. So that's how you get the mean. So we have basic things on how to use the software. One thing to note here, if I go to tab 2, notice now it's 5 hertz. That really wasn't supposed to happen. So now it's set to 5, that's my pen that's doing it, 5 hertz rather than 20 hertz. That's because of the jitter, the uncertainty that is large with the velocity measurements. I'm just going to take some, well, I'm not going to power cycle this thing again. It clearly isn't happy with me. See if I can take data. Yeah, that's not working out for me. Well, I guess I won't take data here, but it has a lot of jitter when you're doing the velocity measurement. And the final tab has position versus time and velocity versus time that you're going to use. So I think I've talked about most of the functionality we're using here. So hopefully you are now ready to do a good job on your lab.